Okay. So once again, all things decimal are what we're talking about today. We want to be able to round to the nearest or to a given decimal place. If it tells what to round to, we should be able to round to it. Typically, we're looking at the values, the place values to the right of the decimal point. Then if it asks you to round to the nearest whole, you're going to round to the 1. They could ask you to round to the nearest 100. Typically, what we're looking at, though, is the decimals. And typically, so let's look at this, the first one to the right. It's the 10th place. The 10th, you look over here to the left, it's 10. So the difference between the left and right of the decimal place is indicates a fraction, right? So if we, it indicates a fraction with a denominator of 10 in particular, when you say 10 or 100, so a power of 10. All right, so if we're rounding to the nearest place value, look and see what they ask us to round to. Rounding to the 100th place. The first thing you need to do is find that place value. So in this number 18.379, so this is the 10s, these are the 1s, this is the 10th, the 100th, and the 1000th, right? So if we're rounding to the 100th place, find the value that is in that spot. So 7 is in the 100th place. From there, there's two things that can happen if we're rounding. It can stay a 7, or it can go up to an 8, right? So if we're looking to the, we're starting at 7 and we look to the right. If that number is 5 or greater, then 7 goes up to 8. If it's not, it stays at 7 and we drop to 9. Right, so we're looking here. 9 is greater than 5, or 5 or greater, so we're going to round that to 18.38. You're writing that in your notes. You're writing that in your notes. Put your name and date on your notes. We're looking for rounding to the 10th place in the same number. We determine what is in that 10th place. In this case, it's a 3. We look to the right. 7 is also 5 or greater. So there's two options. It stays a 3 or it goes up to a 4. So since that number is 5 or greater, that goes up to a 4. It's 18.4. And now the whole number. So the nearest whole number, after the nearest whole number, it's going to be the 1st place. Right? If you want to make yourself a note, 1s or whole number, that's going to be the same thing. So we look at that value. If you're not sure about that, so 1s is also nearest whole number. And we're going to talk a little bit more about exactly what a whole number is later in this lesson, but a whole number has no decimals and no fractions. So it makes sense that you're lopping off the decimals to the right. So what does this round to if we're rounding to the nearest whole number? What's that answer going to be? So 18 is the 1st place. We look to the right. What's it going to be, Jewel? It's going to be 18. 3 is less than 5, so it rounds to 18. Any questions? Okay. We are not going to multiply or add and subtract these by hand. If we were adding and subtracting them by hand, we would line up the decimal points vertically, and just like we used to do long addition and subtraction, long multiplication and division. We're never going to do that here. So really what we're going to do right now is practice using a calculator. This is negative 23 and 5/10 minus 41 and 38/100. So make sure you know how to enter the negative on your calculator. That's what we're practicing right now. Turn your calculator on the negative list for the numbers on this calculator. So make sure you remember how to use your calculator. That's really what we're doing here. Again, we already got yours. Angel, what'd you get for A? Negative 64.88. What place value is that 8 right there? So we will read this negative 64.88 100 if we want to read this place value there, right? And it's important for us to know how to read that because in just a minute or two we're going to review how do you write the decimal as a fraction, right? So it's important to know we can read it that way, we can identify the place value, so we need to write it as fractions there. 14.65, 14 and 65 is 100 minus 20. What do you get, Ashlyn? Negative 5 is 35 100, right? So everybody knows how to use the negative button. Same thing here. Well, let's pause for a second. We are not going to do it by longhand, but if we're multiplying decimal places, remember you line up, you do not line up the decimal point. You just line everything up right justified. You multiply it like you would if there weren't a decimal point, and then you count up the decimal places and start at the right. In this case, 1, 2, 3, 4. Multiply it by hand and count from right. 1, 2, 3, 4 decimal places. That's why you put your decimal point in there. If you had to do it by hand, okay? I cannot imagine there's ever going to be a time ever now until you have children that just try to teach how to do this that you're going to be doing that. So if you did multiply it already, go ahead and multiply it. Once again, just basically practicing that, making sure you know how to use the buttons. Give me a second, Miss Holmes just said she has a list here. I'm going to see if any of you guys are on the list so you could go get your Chromebook. No, you are not. Sorry about that. All right, did you get negative 15, 8,925 10,000? Did you get negative 15 is 8,925 10,000? Okay. All right, we are going to practice multiplying a decimal by a power of 10 using the shortcut. Remember, all the decimal places, all the place values are labeled as power of 10. Anytime you want to multiply by 10, or 100,000, anything that's any power of 10, we just move the decimal point. Obviously, we can just multiply on the calculator, right? But if you want to use your shortcut, you want to multiply 5.63 by 10, tell the number of zeros in that number, and just move the decimal point. So there's 1 0, so you're going to move this decimal point one place. That's 66.3. Going to multiply it by 100. 2 zeros and 100, so there's 2 places, right? Same thing with 1,000, there's 3 zeros, so we're going to multiply it, we're going to multiply it by 1,000 just by moving the decimal point 3 places. You can do the same thing if you're dividing by these powers of 10, but you move it to the left instead of the right, right? If you can't remember which direction to move it, divide in your calculator, divide or multiply it in your calculator. But also, if you're multiplying, you're getting bigger. If you're dividing, you're getting smaller. Typically, unless you're dividing by a fraction, right? But we're not, these are never going to be fractions. We're always talking about powers of 10, right? Questions? That can save you a little bit of time if you know that trick. If we were dividing this by hand, we'd use long division, but right now we're just practicing using decimal places. So let's divide negative 25 and 65 100ths by negative 600ths. Mark that, go, Ben. Multiplying. If you were dividing these by longhand, divide them without the decimal, then you do the same thing. You add the correct number of decimal places to add. What'd you get, Ben? Nope. Not too big anyway. How big a number? Like off your display? Yeah. So clear your calculator out 3 times. Good math awareness. You were pretty sure that was not the right number. What'd you get?
I got the same. Got 427.
Yeah.
That's right?
Yeah, that's not that big a number.
Oh.
I thought you were talking bazillions or something.
Oh, no, that's what I got the first time.
427 and 5/10. Remember what dividing means? It means how many of these 0.06 are in this number, right? So that's a really small number. How many times does this occur? How many of these do you have to reach that value? Okay. So how do we write a decimal as a fraction or a fraction as a decimal? So this gets back to knowing those place values. To the right of the decimal place, so the 3 is in what place value? 3 is in what place value, Tiana? And this one is in what, actually? And the 4 is in what, Leo? Okay. So the last one, that's the denominator, right? This is 3 in red is 374,000. And so that's the denominator of a fraction. Right, so if we're reading that correctly, and unfortunately, we normally read that as 0.374, right? But if we read that correctly, we say these two things exactly the same way. 374 1,000. So you write it as a fraction based on that last place value as your denominator, and then you simplify. So 4 is an even number, 0 is even. So we are going to simplify by dividing both by 2, and that's the only thing that will come out of there is 2. So what if you want to convert a fraction to a decimal? Remember that a fraction is just a decimal problem, right? So we're just going to divide top divided by bottom, numerator divided by denominator. So and then we could do it by longhand, but we're not going to. We're going to do it on the calculator. So it's negative 5 divided by 8. So then negative is in the middle. That means the entire value is going to be a negative, right? We can move it to the top, or we can move it to the bottom. We just can't put 1 in the top and in the bottom, right? That's divided by negative, which is a positive quotient. So all we're going to do there is divide on our calculator. We should get negative 625 1,000. Any questions? Okay. Converting percent to decimal, and converting decimal to percent. That's what we're talking about next. So if we convert a percent to a decimal, we're going to do the opposite of using that shortcut to multiply by 100. We are going to lop off that decimal point, and then we're going to move this back 2 places. So we're dividing by 100, which means you can just move the decimal place back 2 places. Once again, if that confuses you, especially in assessment, check yourself. Just divide by 100 on a calculator, right? So 0.62. 135%. Remember that a percent is a part of a value. 100% is equivalent to 1. You turn that into a decimal. 135%, we're going to drop the percent sign and move it 2 places or divide by 100. So 135% as a decimal is 1 and 35/100. Same thing here. We're dropping the percent, moving it 2 places to the left. It's 137/1000. If we're going the other way, we multiply by 100. We just multiply that, move the decimal point 2 places to the right, and add the percent symbol. If you're writing something as a percent, it should have a percent symbol. 51 is not the same as 51%. Talking about percent, we're referring to something in particular. That's the purpose of that concept. 2 places to the right puts this at 125 and add the percent. 2 places to the right on the last one. 1, 2. Puts you at 9.3%. Some kids are confused about having a decimal point in a percent. Perfectly okay. It's also okay to have a percent that's less than 1. So it could be 0.01%. I don't know why that's more confusing for kids, but it is, right? It's less than 1%, 1/100 of 1%. And that's okay. All right, if we're finding the square root of a particular value, so that symbol there, it says that radical with the m under it, so that's the little symbol here is a radical. The m underneath that is a radicand. If there's not an index here, you guys probably remember that means it's the square root of that number. If we want to take a different root, there needs to be a number there. Remember, all these external notes that you're not seeing in your notes are in the chapter readings as well. If we're taking the square root of numbers, typically they want us just to give them the positive square root. We know the square root is the factor that you multiply by itself to get that radicand. So 25 is the radicand. What number do we multiply by itself to get 25, Ethan? What number do we multiply by itself to get 25? What's the square root of 25? Yes. And we do know that -5 times -5 also equals positive 25. But unless they ask for them for both roots, we give them just the positive. Keep in mind that a radical is a grouping symbol as well. So you evaluate what's under the radical first, and then you look at what's happening behind it. The square root of 121, the value that multiply by itself to get 121 is what? Jewel? 11. Okay. Now, the grouping symbol comes into play here, because this is not the square root of -144. Remember, we read this, especially if it's hanging around by itself, we read this as the opposite of the square root of 144. So we evaluate the square root of 144 first, and we're going to use that positive square root. But since they said the opposite, then we're going to evaluate that as -12. Any questions on that one? So rational and irrational. So real numbers, so we're not talking about any imaginary numbers. We're talking about just real numbers, basically just the numbers you use all the way up throughout French geometry. All the numbers you add, subtract, multiply, and divide when you were a kid in elementary school, right? So real numbers consists of a set of rational numbers and a set of irrational numbers, right? So we need to be able to categorize any numbers they give us into these groups. Within the category of rational and irrational, within the category of rational, there's a subset of other categories, right? We need to be able to identify them down to and use every category that's possible that they could be categorized in. Remember that a rational number is any number that you can write as a fraction. An irrational number cannot. Rational numbers, if you evaluate a value and the decimal is terminating or it repeats, then we could say that it's a rational number. If it's an irrational number, you evaluate it in your calculator, it's going to be a non-repeating, non-terminating decimal. So, you very often will see these categories in a Venn diagram, right, where the whole big, the square, the rectangle are the real numbers. They've got a circle for rational numbers and a circle for irrational numbers. Within that, each of these subsets, you'll know there's no other category that the number is irrational. It can't be written as a fraction. Then it is an irrational number and a real number, nothing else, right? But within rational numbers, numbers that can be written as fractions, we have 4 different categories. If it can be written as a rational number, it's a fraction, then it may also be able to be categorized as a counting number, a whole number, or an integer, or more than one of those. So we're going to start at the bottom with the counting numbers, which are also natural numbers. Pretty sure I mentioned before when we're talking about counting numbers and natural numbers, those are the numbers you teach a baby to count with. So many babies learn to count up to 10 by scraping little slobbery Cheerios across a high chair string, right? 1, 2, 3, we're teaching them to count. We don't teach them to count with fractions or decimals, right? The counting numbers start at 1. Here's a super hard concept for a baby. Counting numbers start at 1. That's what we start counting things, all right? If I count rows along the wall, 1, 2, 3, 4, right? Count it. Now I'm looking at whole numbers, and you'll notice counting numbers, no decimal, no fractions, right? If you remember what a counting number is, it helps you categorize it, right? So think about what it actually is. Whole numbers are counting numbers plus the number 0. Right? So you'll know no decimals, no fractions. So 2 is a counting number, but it's also a whole number. Well, look up to the next category. So integers are whole numbers plus negative whole numbers. Right, so all positive and negative, and 0, no fractions or decimals. So 2 is a counting number, a whole number, and an integer, and a rational number, because anything in that category is a rational number. So what falls under just the rational? Are there any values that are just rational numbers? Yeah, any 1/3, that's a fraction, right? Because that's a rational number. If you put it in the calculator, it's 0.3 repeating, right? So since that can be written as a fraction, that's a rational number, but it's not accounting a whole or an integer. Make sense? 0 is not a counting number, right? Negative 2 is an integer and just a rational number and a real number, right? 1/4, rational number, no other categories. But when you're doing these, you have to be able to identify all the categories that number belongs to, okay? So let's look at the examples up here that we're given. Giving these numbers, they want us to list all of the whole numbers first. So of these 1, 2, 3, 4, 5, 6 values, can you tell me which numbers are whole numbers? Can you tell me which numbers are whole numbers? Noah? -7? So look at whole numbers. What does whole numbers start with? 0, right? So what is the -7 not a whole number, right? 8. Yeah. 8 is the only whole number there. Integers. What are the integers in this list? What are the integers in this list, Hudson? 7, 8, and also the opposite of the square root of 64, right? So we're going to say the opposite of that, right? And so the opposite of the square root of 64, the square root of 64 is 8. The opposite of that is negative 8. Negative 8 is an integer. So if we're given something in radical form, we need to evaluate that, see if it can be evaluated and rewritten, and now we know those are our integers. Rational numbers. What are the rational numbers in this list? Well, let's bump that one. Let's do the irrational numbers in this list. The irrational numbers are over here. Can irrational numbers be written as a fraction? Yeah. Non-repeating, non-creating decimal. Okay? So is negative 7 irrational? Is 14/5 irrational? Is 8 irrational? How about the square root of 5? Everybody put the square root of 5 in your calculator. Remember how to use the caret on there? Or no, not the caret, but the square root symbol in there? It's, help me identify the square root symbol. There it is, the second function on that one. So you're going to do 5, and then second, and that's square. Oh, that's what you got. I forgot, you can do this in the other order. So let's do second, x squared button, 5. So, everyone, alright, so let's practice finding the square root in here. I use this calculator, so I have to find it. I had to find it too, especially at the beginning of the year. So the square root on your calculator is the second function is on the x squared button. So you're going to get the second button first, then you get the x squared button, then you put in 5, and then you get equals. So if you did not get that, that's how we do it. You get anything? Yes?
Second square root.
You had a second there. All right. So 5 is irrational. Square root of 5 rather. Is there anything else? Is 5.9? Terminating decimal could also be written as 5 and 9/10, right? And we've already established that this is negative 8. So that is the only irrational number. All the other numbers are rational. And remember that they're all real numbers. It's not talking about anything but real numbers here. I think that's it. I'm going to post your problems up on the board. Is there anybody, I know you're still on the copy. Is there anybody that can't access your assignment from another device? Anybody else? And 3, anybody else? Okay, I'll try, but I'm going to set them up to the board for you. The problems you're doing, 241 to 295 odd. Okay? So go ahead and edit this picture, get your name, your date on it. I'm going to put the assignment on the board. Once we have Chromebooks, you're going to pull it up on there.